So let me ask you a question. Does polymorphism actually require inheritance? Now, if you've recently learned polymorphism, there's a good chance your answer is yes. After all, every example you've probably seen looks something like this. A parent class, a child class, a method being overridden, and boom, polymorphism. Simple. Case closed. Or is it? Because today, we're going one level deeper. We're going to discover something that surprises a lot of beginners. Polymorphism is bigger than inheritance. In fact, Python can achieve polymorphism even when inheritance isn't involved at all. Sounds strange? Good. Because by the end of this video, you'll understand exactly how that works. We'll explore duck typing, behavior-based design, and real examples that show why Python's approach to polymorphism is so flexible. So let's begin with a simple experiment. And trust me, the result is probably not what you're expecting. Now let's test our assumption. Suppose I create two completely different classes. Not parent and child classes. Not related classes. Just two random classes. Let's say we have a dog and a robot. Now obviously these two have nothing in common. A dog is a dog. A robot is a robot. And unless technology has advanced a lot more than I think it has, one of them probably needs charging. Now imagine both of these classes contain a method called speak. The dog says. Bark. The robot says. Beep. Pretty straightforward. But here's the interesting question. If I place both objects inside the same collection and call speak on each one, what do you think will happen? Will Python complain? Will it throw an error? Or will it actually work? Because according to what many beginners believe, polymorphism should require inheritance. And right now, we don't have any inheritance at all. So let's stop guessing and test it ourselves. So let's see what actually happens. We create our dog class. We give it a speak method. And when that method is called, the dog barks. Nothing surprising there. Next, we create a robot class. It also contains a speak method. But instead of barking, it simply says beep. Again, pretty straightforward. Now comes the interesting part. We place both objects inside the same collection, and then we loop through them. For every object we find, we call speak. That's it. No inheritance. No parent class. No method overriding. Just a dog. And a robot. So what happens when we run the program? Let's find out. Look at the output. The dog barks. The robot beeps. And Python doesn't complain at all. Duh. Which is probably not what some of you were expecting. Because according to the traditional way, beginners think about polymorphism. This shouldn't have worked. And yet, it worked perfectly. So the real question isn't whether it worked. The real question is, why did it work? So why did this work? At this point, many beginners start looking for inheritance. Maybe the dog secretly inherited from something. Maybe the robot inherited from the same parent class. Maybe there's some hidden relationship somewhere. But there isn't. These classes are completely unrelated. And that's exactly what makes this example interesting. You see, Python doesn't always care about what an object is. Python often cares about what an object can do. Let me say that again. Python cares more about behavior than identity. If an object knows how to respond to a particular method call, Python is usually happy. It doesn't stop the program and ask, "Excuse me, are you part of the correct family tree?" It simply checks whether the object can perform the requested action. And if it can, the program moves forward. This idea is known as duck typing. You've probably heard the famous saying before. If it walks like a duck and quacks like a duck, then it's probably a duck. Python follows a very similar philosophy. If an object behaves the way we expect, Python is willing to work with it. And that's why our dog and robot example worked perfectly. Python wasn't interested in their relationship. It was interested in their behavior. Now, let's visualize what's actually happening behind the scenes. Imagine Python receives this method call, speak. The first thing Python wants to know is very simple. Does this object know how to speak? That's it. Nothing more complicated than that. Let's start with the dog object. Python sees the method call. It checks the dog. And sure enough, the dog has a speak method. So, Python executes it. Simple. Now, let's do the same thing with the robot. Again, Python receives the method call. It checks the robot. The robot also has a speak method. So, Python executes it as well. Notice something interesting here. At no point did Python stop and ask, wait a second, are these two classes related? It never asked, because that wasn't the requirement. The requirement was much simpler. Can this object respond to the method I'm calling? If the answer is yes, Python is happy. If the answer is no, that's when you'll see an error. And that's the beauty of duck typing. The focus shifts away from inheritance and moves toward behavior. What an object can do becomes more important than what an object is. Now you might be thinking, this is interesting, but where would we actually use something like this? Let's imagine we're building a notification system. Whenever a user places an order, we want to send a notification. Simple enough. But here's the catch. Some users prefer email, some prefer SMS, and some want push notifications. Now imagine writing completely separate logic for every single notification type. That would get messy pretty quickly. Instead, we can give each notification type the same method. Send. Email knows how to send an email. SMS knows how to send a text message. Push notification knows how to send a push notification. And the application simply calls send. That's it. The command stays exactly the same. The behavior changes depending on the object receiving it. And if that sounds familiar, that's because you've just described polymorphism. This is one of the reasons developers love polymorphism. New notification types can be added easily. Existing code stays clean. And the application becomes much easier to maintain, which is exactly what we want when building real software. So let's clear up one very common misconception. A lot of beginners think inheritance and polymorphism are the same thing. They're not. Inheritance is one way to achieve polymorphism. But inheritance itself is not polymorphism. That's an important distinction. Think about what we discovered today. Our dog and robot classes weren't related. There was no parent class, no inheritance hierarchy, and yet polymorphism still existed. Why? Because both objects could respond to the same method call. And that's the key idea I want you to remember. Polymorphism is not about relationships. Polymorphism is about behavior. The moment different objects can respond to the same interface in their own way, polymorphism enters the picture. Inheritance can help us achieve that. But inheritance isn't the requirement. Behavior is. Which is actually a very Python-like way of looking at the world. Python doesn't care about titles. It cares about results. Can the object do the job? Great. Let's move on. And honestly, that's one of the reasons Python feels so flexible compared to many other languages. So let's quickly put everything together. In the previous video, we learned that polymorphism allows the same method call to produce different behaviors. And today, we took that idea one step further. we discovered that polymorphism doesn't always need inheritance. We saw completely unrelated classes working together through a common interface. We learned how Python focuses on behavior rather than class relationships, and we explored the idea of duck typing, one of the features that makes Python so flexible. So if there's one thing I'd like you to remember from this video, it's this. Polymorphism is not about what an object is. It's about what an object can do. The moment different objects can respond to the same action in their own way, you're looking at polymorphism. And once you start noticing it, you'll find it everywhere in software development. Anyway, I know some of you are sitting there thinking, what on earth did I just watch? And honestly, that's completely normal. Because if everything in computer science made sense on the first try, then computer science probably wouldn't exist in the first place. And yes, I know a few concepts in this video probably went straight above your head, which is obvious. Because if you actually had a brain, you probably wouldn't have chosen computer science in the first place. And now look at us. Learning classes, learning inheritance, learning polymorphism. We're all suffering together. So what can we do about it? Simple. You have to fall in love with computer science. There is literally no other option available. Because trust me, the deeper you go, the more interesting it gets. One day, you're learning Python. The next day, you're arguing online about which programming language is better. And somehow, that becomes normal. Now, as for subscribing, I already know what's going to happen. You'll watch the entire video, learn something useful, close the tab, and disappear. Because after all, I'm not a female YouTuber, so my chances were already low from the beginning. But if you did enjoy the video, consider subscribing, and I'll see you in the next one.